Okay, folks, today's lesson is about finding an equation for a line given 2 points. So this is straight from your textbook. Linear models can be useful for making predictions in many situations involving direct and partial variation. If you know 2 points of information, you can find an equation for the line. So first things first, we have to find our slope. So using our 2 points, we're using our slope formula. And then once we have our slope, we sub one of our points into y equals mx plus b to find b. And then that's our equation. So let's try it. Here we have a line that's passing through points 1, 2, and point 5, 10. We need to find an equation for our line. So, let's see, slope is y2 minus y1 over x2 minus x1. Remember, order doesn't matter as to which one's 1 and which one's 2, but you have to be consistent. So if I put the first point first, 2 over 1 minus minus, second point second, the y value is 10, the x value is 5. And what does that give me? Negative 8 over 4. Ooh, negative 4. Negative 8 over negative 4 turns into a positive 2. So I've got that part. So then I've got y equals mx plus b. So I know now that my slope is 2. And then I pick either one of these points. It does not matter. I'm going to pick the 1, 2 because the numbers are smaller. It makes my life easier. So the y value, remember, is our 2. The x value is the 1. So for y, we're going to put in 2 equals 2 times our x value is 1 plus b. Let's simplify and rearrange here. So we've got 2 equals 2 times 1 is 2 plus b. So let's see, minus 2 from both sides. 2 minus 2 is 0. Oh, b is 0. Therefore, y equals 2x plus 0, which is the same thing as saying y equals 2x. And that's the equation of my line. All right, let's see the next one. We have a line passing through the point 3, 2 and a line passing through the point 6, 8. And again, it doesn't matter which one you put in which order. You just have to be consistent. So y2 minus y1 over x2 minus x1. So this time, I'm going to put this point in first. So I've got 8 over 6 minus minus 2 over 3. 8 minus 2 gives me 6. 6 minus 3 gives me 3. 6 divided by 3 is 2. Well, that's not very creative. Okay, well, there's your slope. mx plus b. Y equals 2x plus b. So picking one of my numbers, I'm going to pick the 3, 2, because again, it's smaller numbers. So my y value is 2, and then I've got 2 times my x value, which is 3, plus b. Simplify it out. 2 equals 6 plus d. Rearrange, so we have to bring the 6 to the other side. So instead of it's got its little plus in front, so we're going to subtract it. And that gives me 2 minus 6 gives me negative 4 equals b. Therefore, y equals 2x minus 4. Now let's do a word problem. Yay! Let's say it costs a fixed amount of money for access to a climbing gym. It's going to cost a total of $46 for 18 hours. So that's going to give me a point. And it costs $70 for 30 hours of play. So there is another point. To determine the fixed cost, variable cost, find the equation, graph it, and then we're going to use the graph and the equation to find a value. And we're going to see, let's just compare which one's easier to do. So to do this, let's set up our graph here. Okay, so I've set my scales here. So when I'm talking about money for hours of play, so the money is going to be what goes on the y-axis, right? That's the dependent. So on my y-axis, it's going to be cost in dollars. And my hours of play, that's my independent, right? Because the cost depends on my hours. So my time of play, so that's in hours. Okay, so title would maybe be, I don't know, climbing gym costs. Sure. Okay, and then let's pop down some numbers here. So 18 hours of play is going to cost me $46. $46. There's a nice little dot there. And 30 hours of play is going to cost me $70. Get in the right spot if I go there. Okay, so I can draw a line and I can figure things out. To be extra accurate, to figure out my equation, I would do m equals y2 minus y1 over x2 minus x1, remembering that my x was 18 hours for 46 and 30 hours for $70. So that would give me 46 over 18 minus 70 over 30. So what's that going to equal? So we've got negative 24 over negative 12. What is with the 2's today? My goodness. So there's my slope. So what's my y-intercept going to be? Well, let's figure that out. Y equals mx plus b. So I have a slope of 2. Let's pick one of these points. Really doesn't matter. I'm going to use the 30 and 70 because those look like nice numbers. So 70 equals 2 times 30 plus b. 70 equals 60 plus b. So we're going to minus 60 from both sides. And what does that leave us? 70 minus 60 gives me 10 equals b. So my equation of my line is going to be y equals 2x plus b. I could have used, I don't know, cost is 2h for hours maybe, plus, oh, b is 10, sorry. Ha ha ha, silly me. Either way, so now I know my y-intercept is at 10. And if I go to draw a line, I should hit every single one of these points very nicely. So let's see, line it up with 10, dot, and dot. Excellent. So it's much easier having a nice, easy to read y-intercept point in order to make my line, because then when I'm estimating, I don't have to worry so much about it. All right. Use the graph to determine the cost of 25 hours of play. So let's see. 25 hours of play is in here. So remember, we read up and then we read across. So that means I'm looking at, what's that, 60? So 60 would be my answer. Graph to determine the cost of 24 hours or 25 hours of play. So that's going to cost me $60. And because it's inside my points, it would be interpolate. Use my equation to determine the cost of 25 hours of play. All right, so we got to scroll down here and give myself a little bit of space here. So if I want to figure out my cost of 25 hours of play, well, I can just stick the 25 in for my h, right? H is 25 plus 10. C equals, what's that, 50 plus 10, so $60. Therefore, it costs $60 for 25 hours of play. So let's look at this in total. I think I missed one of the questions up near the top. Hang on here. Determine the fixed cost and the variable cost. Ooh, well, the fixed cost, well, that's going to be my y-intercept here. So we figured that out here. Okay, so let's maybe highlight that one because we kind of did that all over the place here. So our fixed cost is our y-intercept. So we figured that out here. So that's our y-intercept. And then our variable cost, well, that's how much it costs per hour. So that would be our slope value. So our slope is our variable cost, and our fixed cost is how much it's cost just to step into the gym. Cool.